wondering where I am, right? Well, I am in space. And do you know what that is? That is our galaxy, and it's called the Milky Way. Do you see that? That bright light is our solar system. That's where we live. Come, let's take a closer look at our solar system. Zoom in. This is how our solar system looks like, with planets revolving around the sun. The sun is the main source of light for all the planets. Our solar system has 8 major planets. Mercury. Mercury is the closest planet to the sun. A year in Mercury is 88 days long. And you know what? You will see Mercury from Earth in the year 2016. Venus. Venus is the second planet from the sun, and it is the hottest planet in the solar system. That's because it has high amount of carbon dioxide, which traps heat inside it. Earth. This is my favorite planet, for obvious reasons, of course. Earth is a unique planet with suitable climatic conditions, landforms and water bodies, which support life in all forms. Moon is the natural satellite of Earth. Mars. Mars is often known as the red planet because of its reddish appearance. It is home to some of the largest dust storms, which can continue for months and cover the entire planet. Jupiter. Jupiter is the largest planet of our solar system. It also has 4 moons. One day in Jupiter is just about 9 hours 55 minutes, making it the shortest day of all planets. Saturn. There are about 150 frozen moons around Saturn. The largest one is called Titan. This planet has beautiful rings around it, made of dust and ice. Uranus. Uranus is a very, very cold planet, with temperatures dropping to about minus 224 degrees Celsius. It takes about 84 Earth years to revolve around the sun, out of which it gets direct sunlight for 42 years, and the rest remain in darkness. Neptune. Neptune takes about 165 Earth years to revolve around the sun. It is also known as the ice giant, and it has about 14 moons. Trivia time! Did you know that we also have 5 dwarf planets in our solar system? Ceres, Pluto, Eris, Makemake, and Haumea. Jupiter's moon Ganymede has more water than the Earth. Whoa, that's so much information for today. I am tired now, so this is me zooming out. Tune in next time for some more fun facts. Hey friends, are you wondering where I am? Well, I am in space. But hey, I have traveled 4.6 billion years back in time, exactly when our solar system was formed. Well, since we don't have that much time, let me fast forward the process and tell you about the formation of the solar system. Zoom in. It is believed that our solar system was formed when a cloud of dust and gas was disturbed by an explosion of a nearby star called the supernova. The star exploded with a bang, and its effect traveled in waves all around. These waves squeezed the cloud of dust and gas, resulting in its collapse. All the little pieces of matter that started out running away from each other got pulled back together by gravity. Soon the cloud began spinning at a tremendous speed. And there it was, a beautiful solar nebula in the making. Just for some extra information, a solar nebula is a large cloud of gas and dust from which the sun, planets, and other solar system bodies like asteroids, meteors, and moons were formed. Okay, so let's now continue from where we left off. When the spinning slowed down, the center of the solar nebula became hotter and denser, which was surrounded by a disk of gas and dust that was cool at the edges. At the heart of the nebula, there was a ball of hydrogen gas whose pressure and temperature became quite huge, and the particles began to fuse together. There it was, a new powerful star coming into being. Yes, that was our sun, shining like a fiery ball. There were infinite number of particles that began to stick together and form clumps. Some clumps got bigger and bigger and bigger, forming planets and moons. Aha! So now you know how the planets were born, isn't it? Did you know that the sun takes up 99% of the solar system's mass? This means that we are technically living inside the atmosphere of the sun. The rocks that belong to Mars have been found on Earth. And guess what? We didn't bring them here. Does that make you raise your eyebrows? Huh? Time for me to get back to Earth. Tune in next time for more fun facts. This is me zooming out. Oh, whose birthday is it, little kitty?
Sun. Whose is Sunday?
Well, unfortunately, we don't know the exact date of the sun's birthday. However, we do know something about its birth and how it came into existence. So in today's episode, let us explore the creation of our beloved sun and answer a burning hot question. How was the sun formed? Zoom in! There are billions of stars in our galaxy, but the great glorious sun holds a special place in our lives. That's because its gravity keeps the solar system together, holding everything from the biggest planets to the smallest particles of debris in its orbit. Not only that, the connection between the sun and earth drive the seasons, ocean currents, weather, radiation belts, and auroras. But the vital question is, how did our sun come into existence? Well, it all started 4.5 billion years ago in the Milky Way galaxy's Orion Spur, when waves of energy traveling through the space pressed together the clouds of gas and dust called a solar nebula. These clouds mainly consisted of the gases like hydrogen and helium, but some of it was made up of the remaining remnants of dead stars. Then, as the nebula collapsed because of its gravity, most of the material was pulled toward the center as it began to spin faster, causing the cloud to flatten into a disk. And in the center of this disk formation, the material continued to clump together as the matter condensed into a burning ball of gas to form a protostar. Then over the next tens of millions of years, the temperature and pressure of the material inside increased, jump-starting the fusion of hydrogen that made the sun we know today. Today, with a radius of 432,168.6 miles, our sun is the largest object in our solar system. It is so big that it would take 332,946 Earths to match the mass of the sun. and can fit all 8 planets inside it nearly 600 times. The sun can be divided into 6 layers, starting from the corona. Next comes the chromosphere, then the photosphere, followed by the convective zone, radiative zone, and finally the core. In terms of atom count, the sun is made up of 91% hydrogen that acts as its fuel, 8.9% helium, and 0.1% heavier elements like nitrogen and carbon. The temperature at the surface of the sun is about 5,600 Celsius, which rises as we go inward towards the center of the sun, where it reaches around 15 million Celsius. Now, that's really hot. But here's the thing, my friends. Like all stars, the sun will someday run out of energy. Yes, scientists predict that the sun is a little less than halfway through its lifetime and will last another 6.5 billion years. After that, it will swell to become a red giant. Eventually, it will shed its outer layers and the remaining core will collapse to become a white dwarf. Slowly, the white dwarf will fade and will enter its final phase as a dim, cool object known as a black dwarf. Did you know the sun is the closest star to our planet? Yes, the sun is 93 million miles away from the Earth. Hope you learned something new today. Until next time, it's me, Dr. Binocs, zooming out. The great glorious moon. I hope someday we'll learn about its great glorious past. Yes, little kitty. Even after all these years, scientists are still unsure about the moon's exact origin. And all we have is a few theories.
So share them.
As you say, my curious cat. Hey, friends, I know you are equally curious to learn about the moon's backstory. So, in today's episode, let us shed some light on the best theories we have on the formation of the moon. Zoom in! We learned so much about our natural satellite in your previous videos, right from its different phases to its eclipse, and even explored the possibilities of what will happen if the moon disappeared. So, I request you to please check these videos once. The links are in the description below. Now, when it comes to the moon's formation, the Earth plays a significant role in its birth. Yes, in its 4.5 billion years of lifespan, planet Earth has seen several asteroids shooting towards it with great force. Some of them collided with the Earth and got destroyed, while many of them hit the surface, creating bowl-shaped depressions called craters. And most of them missed the hit and kept flying ahead in space. Though most traces of the Earth's past have long since been destroyed, but we can find clues for most of it. And that's why scientists have come up with different theories about space formation, including the formation of the moon, starting with the capture theory. According to this theory, the moon was formed elsewhere in the solar system and was wandering in space aimlessly, unaware of its future. But when it came closer to our Earth, it was captured by its gravity. And since it is still stuck in the gravitational field of our planet. The next popular theory is called the accretion theory. This theory suggests that the moon was created along with the Earth during its formation. But this notion died out quickly as it could not define the speed of the moon. Another popular theory is called the fission scenario. According to this theory, the Earth was spinning so fast around its axis that a small part of it broke away and began revolving around the planet. But again, we didn't have much evidence to prove this idea. And soon we came up with the most concrete and widely accepted theory, which is the giant impact theory. Yes, according to the giant impact theory, millions of years ago, even before the Earth and the Moon, there existed Proto-Earth and Theia, a planet almost the size of Mars. One day, when these two bodies collided with each other, and due to the explosion of heat, the Proto-Earth and Theia melted only to form as a new giant body that we today known as the planet Earth. Only the small part of the two planets collected near the Earth's orbit, which with time formed into the moon that revolves around our planet. Trivia time! Did you know the size of our moon is almost equivalent to that of the size of the planet Mars? Also, you won't believe it, but the moon's surface is actually dark. Hope you learned something new today. Until next time, it's me, Dr. Binocs, zooming out. Let's go home, Kitty. Hope someday someone will find the real story behind the moon's formation. Never mind. What are you making, little kitty? For that, you'll need more than just clay.
Why?
That's an excellent question. Hey friends, in today's episode, let us see the process behind the creation of our beloved planet and answer a crucial question. How did the Earth form? Zoom in! Planet Earth, a giant mass of water and mud revolving in space, and the only known home sweet home formed just for us, as it gives us food to eat, water to drink, and air to breathe, making it a perfect breeding ground for life to evolve. But have you ever wondered, how did this giant planet come into existence in the first place? I'm sure you did. So, let me tell you this astonishing story of the Earth's formation. Well, it all began a long time ago, which is about 15 billion years ago, when the whole universe was inside a tiny bubble called the cosmic egg. Then about 13.8 billion years ago, the little ball bubble began heating up and generating energy until it finally exploded with a bang. Today, we call this massive explosion the Big Bang. You can check our video on the same. The link is in the description. Then about 4.5 billion years ago, when the universe began to cool down a bit and settled into its current layout, everything started to spin, forming mighty wind and gravity. And over time, one such gravitational force from the remnant of a dead star started pulling the giant dirty gas cloud. This cloud got denser and denser in its center and formed an accretion disk. Then, in the next 10 to 20 million years, other small particles of dust, rock, and gas started sticking together, creating larger objects, until it became a sphere and large enough to be called a planet by today's standard. And young Earth was formed. At this point, the Earth's surface temperature was a burning mess, with seas of lava and a poisonous atmosphere. Not only that, various comets, asteroids, and other cosmic elements constantly attacked it from all sides, making it boil more and more. But soon, things took a dramatic turn and the cosmic attack reduced. And so, as the temperature of the Earth cooled down, water from the inside of the Earth rose to the surface, formed steam, and rained back on the ground to form oceans. Even other meteors brought more water to our land in the form of ice. So gradually, the Earth cooled down and the surface formed a thin crust. Meanwhile, the volcanoes on the ocean's bed blew magma to the top, which eventually cooled down to form volcanic islands that joined together to create a single giant continent called Pangaea. And inside the Earth, the hot rock continued to move around, moving the crust below and breaking it apart through a process called plate tectonics. We have a separate video dedicated wholly to this topic. Please check the link below. And as the Earth's crust moved around, Pangaea broke apart and its pieces drifted away to create the continents we see today. And modern Earth took its form, a place we all can proudly call home. Trivia time! Did you know April 22nd every year is observed as Earth Day? Yes, it was first organized in 1970 to promote ecology and raise awareness of the growing problems of air, water, and soil pollution. So, please do your bit and share this video with friends and family. Hope you learned something new in today's episode. Until next time, it's me, Dr. Binocs, zooming out. Never mind. Are you ready for the ultimate $1 million question, little kitty? Now, tell me, which is the smallest planet in our solar system?
Pluto.
Well, I'm sorry, kitty, but Pluto is the wrong answer. Well, that's undoubtedly a $1 million question. Hey friends, a lot of us grew up reading about the old 9 planets. But later, Pluto was delisted from its status, generating mass confusion about its identity. So, in today's episode, let us explore the reason behind Pluto's planetary fate and answer a fascinating question. Why is Pluto not a planet anymore? Zoom in! Until the year 2005, every school science book taught us that there are 9 planets, namely Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and of course, Pluto, which was the smallest amongst all. This celestial body was discovered in 1930 by an American astronomer, Clyde Tombaugh. And since then, everything was a smooth sail for students across the world. But on a warm day in August 2006, few scientists gathered at the International Astronomical Union in Paris and astounded the world by declaring Pluto as not a planet. After hearing this startling news, the educational unions took notes and changed the matter in the textbooks. But the vital question is, why did the scientist community take its title of a planet away? Well, according to IAU, for a celestial body to be a planet, it needs to fulfill three essential criteria. First, the object should revolve around the sun. Second, the object should be spherical in shape. And thirdly, the area around its orbit should be clear and should not have any equivalent or a bigger celestial body. Meaning, with the help of its gravity, the planet should clear asteroids and dwarf planets out of its way. I know what you are thinking. Isn't Pluto spherical and revolves around the sun? Yes, Pluto does fulfill these two conditions. But in the late 90s, space scientists found out that it doesn't meet the third criteria as it hasn't cleared the neighborhood objects around its orbit, because of which it can't be called a planet and was downgraded the status of Pluto to that of a dwarf planet. But Pluto isn't the only one to be called a dwarf planet. Yes, in the Kuiper belt near Pluto, scientists found two planets, namely Haumea and Makemake, which were just like Pluto. Not only that, but in 2005, the explorers also discovered Eris, which looked bigger than Pluto itself. All these newly found space objects acted like Pluto, but were nowhere similar to other planets in the solar system. So that's when the IAU came up with a checklist to help them classify a planet. And according to it, Pluto and these other planets fit into the first two criteria. That is, it revolved around the sun and was spherical. But they didn't meet the third, which stated that the area surrounding it should be clear. Hence, Pluto was out of Team Planet and landed on Team Dwarf Planet. Trivia time! Did you know Venetia Burney, just 11 years old at the time, suggested the name Pluto in 1930? Also, Pluto is the only planet in the solar system with ice volcanoes and an ocean hidden under its icy surface. Hope you learned something new in today's episode. Until next time, it's me, Dr. Binocs, zooming out. Oh, never mind.